Alright, welcome everybody. Today we're going to talk about alkenes and their reactivity. So let's go through this and talk about what we know about them. The first thing and the real important part of this part of the alkene reactivity is describing the addition reactions that take place. And so what you're going to see is that with an addition reaction, we actually add something across the double bond. Now, alkenes tend to be more reactive than alkenes, and part of that reactivity stems from the fact that you have this double bond. The double bond contains 4 electrons. Those extra electrons have a greater repulsion. There's this buildup of negative charge. Now, elements that have the ability to attract to those electrons, called electrophiles, will be attracted to that extra negative charge in that double bond, and it will react with an alkene more quickly than you would see if you had a single bond where you need some kind of ultraviolet light. What you will see, though, is that there are catalysts used to get these reactions to be quicker, and also sometimes they use some acidic conditions as well to help these reactions occur. So the first type of reaction I'm going to show you is alkenes with hydrogen. And with a hydrogen, you're doing something called a hydrogenation. You're basically taking an alkene, you're adding hydrogen to it, and you're making an alkene. So, I'm sorry, just one second. Sorry about that. So, the alkenes, you add hydrogen to them and they form an alkene. And so you can see that here's my double bond. My double bond is broken, and I now have a saturated hydrocarbon. Now, the conditions for this, you want it to be hot. That will help the hydrogen add to the alkene, and it will help break the double bond. And you want to use a catalyst, a nickel catalyst. And the nickel catalyst, mainly its purpose is to sort of concentrate the hydrogen. Nickel has this uncanny ability to actually hold a lot of hydrogen on its surface, and that creates a really high concentration of hydrogen for a reaction to occur faster. Okay, so the next thing that I'm going to talk to you about is if you have an alkene with a hydrogen halide. And let me just erase this and rewrite it here. Excuse me. And so what we have here is, again, the addition of the bromine and the hydrogen to the alkene. And so what you'll see is some highlights here. We break the double bond. The hydrogen and the bromine, they will add to the first and second carbon. And something interesting that's happening here is, as the HBr gets close to this, what ends up happening is the double bond here. If I were to draw this out for you, the double bond here my Br here, the double bond here, it will actually sort of attack this HBr. And so what you end up having is, you end up having this double bond here attracting to this hydrogen. And the Br gains those electrons in the bond. And so you'll end up with this intermediate where you have the hydrogen that added to that first carbon. The second carbon is now electron deficient. It's a positive. They call that a carbocation. That positive will attract the Br minus, and they will add together. And you will get this C with a Br here and the extra H here. So this reaction occurs pretty easily. There's no special conditions. Notice again the hydrogen halide added across the double bond. What if you have just a straight halogen? Well, again, across the double bond, you will have both of the halogens added, and you'll have the same effect where we showed it with the HCl. You'll have the same thing happen where you form that carbocation. This reaction, it occurs again readily, doesn't need any special conditions. Something interesting about testing for alkenes is using bromine water. Bromine water has this brownish orange color to it. And when you put this bromine water in the presence of an alkene, it changes from the brown orange color to a colorless solution. This is the test for alkenes. If you had, a substance that was an alkene and you wanted to test it, you would add some bromine water to it. And if the bromine water changed from colorless, from brown, orange to colorless, you would know that you had an alkene. Okay, we can also add waters to alkenes, and it will form an alcohol. So when we have an alkene plus water, we'll form an alcohol. Here's my double bond. My double bond again will break. I will add one of the H's from the water and the OH here. Again, you'll have that carbocation mechanism. Some special conditions for this: the water has to be in the steam condition, has to be hot, and you need some kind of catalyst like either phosphoric or sulfuric acid. This is actually how they industrially make things like ethanol. If you try to ferment sugar to make ethanol, it will be a lot more expensive. So here they can do this cheaply and in mass. The last type of reaction I'm going to show you is a polymerization reaction, and this is where linkages of monomers that are repeating units will add together, and you break the double bond, you end up with them all single bonded together. The conditions for this are normally high pressure, high temperature, and some kind of catalyst. So the idea is you're breaking the double-double bonds, everything else is going to hang off from there, and you're going to get this long chain. And just to show you what this might look like with something like propene. So with propene, if I were to form polypropene, then I would have my 3-carbon chain. The double bond would be broken, and to that first 3-carbon monomer, I would form the second, and to that I would form a third, and so on. And I would keep linking them together, breaking the double bond and linking them together. And then I would get this huge chain of, in this case, 9 carbons linked together. And this happens by the breaking of the double bond. So you can try it with the other ones, styrene to make polystyrene, and then the pentuene to make polypentuene, and see how you do. With the styrene, you can, if you want to look it up and see which double bond breaks and how they form, you can do that. Same thing with the pentuene. Alright, so some key points for this part of the unit. The alkenes, they undergo these addition reactions. You could add hydrogen, you could add hydrogen halides, you could add halogens, you could add water. Water will form an alcohol, halogens will form a dihalide, hydrogen halides will form just a halide, hydrogen will take it from an alkene to an alkane. Alkenes can also undergo addition polymerization. We study alkenes because they happen to be very important to make a large range of products like polystyrene. And also remember, the test for alkenes is using bromine water. Alright, so next time we will study alcohols, and we will talk about their reactions, both combusting and also their reaction when they undergo oxidation. Alright, thanks so much for watching, and see you tomorrow.